of odd and even is total. If I say 1 by this is the effect of which one? I can feel it. Cos and x, and this is x times. So this is prepare for advance. You find this formula is 0 if fx is odd. Here minus pi to pi mod x into sin nx dx. This is an odd function. That's why this is going to be 0. Right. And don't move until I finish. You two boys, please don't move. It's very disturbing for me. Okay, I just forget what roll number I am going to ask. Okay, so yeah, please keep 108. Okay. Let me tell. 8 is fine. Okay. See the magic. 1 by 1 square, 1 by 3 square, 1 by 4 square, 1 by 5 square, 1 by 7 square. These are odd numbers. And so, hello everyone. Good morning. I think everyone get their seats, that quiz one sheet, isn't it? How many of you get more than 15 marks, or 15 or more than 15? 1, 2, 3, 4, 5, 6, 7. 7. Okay. Good. Number don't matter, right? Or backbenchers, number don't matter. Okay, but sometimes they matter. Okay, so today we are going to discuss some more questions. Question number 8, question number 9, question number question number 9, question number 10, question number 12, and question number 7. Okay. So we start with question number 8. Fx is equal to Fx is equal to 0. Please keep. From minus pi to x to 0, and 1 from 0 to x to 1. We have to find the Fourier series of f. So, sir told you about Fourier series. Let me know. Fx is equal to a0 by 2 plus summation n cos n then 2n pi x by p plus bn sin 2n x 2n pi x by p. This thing or something else? Either this thing or something else, where an is 2 upon p, where p is the interval of that period of it. So where n is this from minus p to p.
It is simply nx, not 2n pi by 3.
Sorry.
It is simply nx, not 2n pi by 3.
That's why I am asking, because in your questions p is always 2 pi. That's why this whole thing changed to n pi. That's why I am asking what the sir told you. This is a general form for any period. Like your period is 3 pi, 4 pi something. But in your course, I think this is only n pi. Okay. Cos n pi x sin n by x, where a0 is, sorry, not a0, n is 1 upon 2 upon pi minus pi to pi fx into cos n pi x dx. And why I am writing? Because in every question we are going to use it. That's why I am writing it. Because I itself got it. Sine n pi x. Is it correct? Is it correct? So come to this. Fx is this, and we have to find first an and then bn. So what is an? Find it. This is very easy. Let me know what is an. Please. Fx into cos nx dx. This is going to be 2 by pi, 0 to pi, because from minus pi to 0 this is going to be 0 fx, that's why I am not writing that one. This is 1 into cos nx dx. This is 2 by pi, cos is going to be minus sine n pi. Oh, this is an even function, so it is going to be 0. Don't need to write more things. Okay, 0 to pi, this is 0. Is it fine? An is going to be 0. Not. An is going to be 0 when n is not 0. What about n is 0? N is 0 like a0. A0 is 2 by pi minus pi to pi only fx. And that thing is 2 by pi from 0 to pi 1 dx. This is 2. And this is 1. That's correct. Okay. Bn is equals to 1 by pi minus pi to pi fx into sine nx dx. 1 by pi, 0 to pi, 1 times sine nx dx. 1 by pi minus cos nx by n from 0 to pi. This is 1 by, this is very easy integration. Okay, that's why I am not telling you everything. This plus 1 by n. This is 1 by pi, 1 n by n. So this is going to be 2 by n pi if n is an odd number. So I can write this here as 2n plus 1 pi. And otherwise 0. Fine. Is it okay for everyone? Okay. So if it is okay, then we can find fx. Fx is a0 by 2 an cos nx plus bn sin nx. This term going to be 0. This term going to be 0. A0 is 1. So this is 1 by 2 plus summation. Bn is 2 by 2n plus 1 2n plus 1 pi sine 2n plus 1 x. How many people understand this step from this to this? Why I am writing 2n plus 1 instead of n? Even term going to be because see, this is something like this. See. This is b2n sin 2nx plus b2n plus 1 sin 2n plus 1x. Is it fine? Bn can be written as this. Now this is going to be 0, that's why only this now. And this b2n plus 1, like bn is something this. 2 upon 12. Is it fine? Okay, everyone? Okay. Fine. Now I think everyone agrees with me regarding this. I have a question in this. Very interesting. Where is fx? Oh, this is fx. From here, everyone please. From here, tell me what is f0? 1. Correct. From here, what is f0? Half. Why this is not true? Because we always read, learned, fx can be written as there is an Fourier series of fx and fx can be written as subtrigonometric functions. So why this is happening? Like here fx is 1, but here f0 is 1, but here f0 is half. Why this is happening?
Not continuous.
It's not continuous at x is equal to 0. Okay. Any other question? Any other answer? Same answer. Same answer. Okay. So how can we find f0? Like if this is, because see what the convergence theorem said, this is not continuous. Fx has jump discontinuity at x is equal to 0. Jump discontinuity means from minus pi to 0, fx is 0, something this. And from 0 to pi, fx is 1. So fx jump from this to this. Okay, this is called jump discontinuity. At x is equal to 0, fx has jump discontinuity. And if fx has jump discontinuity at that point, let's say at 0, then at that 0 can be obtained from this, not from the Fourier series. Okay, if fx have a jump discontinuity at x is equal to, let's say, c, if I say c, then fc can be obtained by fc minus plus fc plus. This is very easy, not very tough thing. Fc minus means f0 minus means this one, f0 plus means this one. So f0 minus is 0 and f0 plus is 1. Because then when we are approaching from positive side, fx is 1. When we are approaching from negative side, fx is 0. So what is fx here? f0. f0 is 1 plus 0 by 2, 1 by 2, which is also reflected in the function. Okay. But always remember, if fx has jump discontinuity at x is equal to c, we can't find the value of the function from Fourier series. Always remember. We can find the Fourier series using this concept. fc minus f of c minus plus f of c plus upon 2. Average of lower limit and upper limit. Okay. Otherwise, this is convergent. Like if you say what is f2, here f2 is 1, from here f2 is also 1. Only problem is at x is equal to 0, because at x is equal to 0, this function is not continuous. Okay. Alright. Okay. So come to next question. If you have any doubt, you can ask, please. Next question is going to be very interesting, in which we are going to find something. So next question is, question number 9. find the Fourier series of mod x first, and then prove that 1 upon 2n plus 1 square, this is going to be something, and this is going to be. So we have to first find the Fourier series of mod x. Yeah. This is very connected to what you read in sequence and series. This series is going to be convergent. Now we are going to find what is the sum of that convergent thing. Like we read this thing is convergent, but we don't know where it is convergent. Like what is that A or C where it is convergent. Now we are going to find where it is going to be convergent using Fourier series. This is the importance of Fourier series. So this is the importance of Fourier series. Okay. So find it using that formula A0 by 2. Okay, I'm also finding on board. A and 1 by 5, and from this is from minus 5. Quite you are. Wow. That's good. This is the effect of which one? I can feel it. Cos and x, and this is x times. So this is 2 by pi x sin nx by n minus plus cos. Let's start here. From 0 to pi. 2 by pi and this is very easy thing, that's why I'm not telling you, because you are very talented with us. No? Yes. I know. 2 upon pi cos n pi by n square minus 1, and cos n pi is actually minus 1 by minus 1 raised to power n upon n square common. So this is going to be 2 by pi by f. Okay, this is. If you have any doubt, you can ask, please. What about Bn? Always zero. This is very good point. Always zero. Who are agree with always zero? Why this is always zero? He said the Bn is always zero. Minus 1 upon pi minus pi to pi fx into sin nx dx. Because what function and
sin nx is off.
okay.
Yeah.
While you are prepared for advance, you find this formula is 0 if fx is odd. Here minus pi to pi mod x into sin nx dx, this is an odd function. That's why this is going to be 0, right? Why it is odd function? Because if we replace x with minus x, we get minus fx. Correct? Okay. So this is n. Okay. And this is going to be 0 if n is even, and if n is odd, this is going to be minus 4 upon 2n plus 1 whole square if n is odd. Not actually, this is not true. This is 0 if n is even, and this is minus 4 by 2n plus 1. Because if I write 2n plus 1, this means I am writing even number. Okay, so no need to say again even. Yeah. So this fx is equals to, what is a0? What is a0? Okay, we have to find a0 separately. A0 is 1 by pi minus pi to pi fx. This is 1 by pi 0 to pi 2 times fx. This is 2 by pi 0 to pi x dx. 2 by pi x square by 2 0 to pi. This is 2 by pi square by 2. Pi cancel, this cancel, this is 1. Sorry. 1 by pi minus pi to pi mod x dx, and this is going to be 0 because again mod x is n. I was correct. 2 by pi x square by 2 0 to pi 2 by pi square by 2. Yeah, that's correct. Okay. So what we get fx is equals to pi by 2 minus 4 summation 2n plus 1 square into cos 2n plus 1 x. Is it okay? Fine. Okay. Okay. So this is what this is. Fourier series for mod x. Is any change like there we get at x is equal to 0, this is 1 by 2, but here we get 1. Is any change here? Like, is any x where mod x is not continuous? No. So this fx give the complete Fourier series or complete value of fx, whatever you want in between minus pi to pi. Okay? Fine. So now we are going to find summation 1 by n square. For this we put let x is equal to 0. At x is equal to 0, f0 is pi by 2. See very carefully, this is very interesting step. Whole square cos 0. So f0 is 0, pi by 2 minus 4 by pi, summation 1 by 2n plus 1 whole square. So this implies pi by 2 with minus sign is equal to minus 4 by pi, summation 1 by 2n plus 1 whole square. This implies this multiply here, pi square by 8 is equal to summation 1 by 2n plus 1 whole square. Just write it, then I'll tell you what's special in this.
Then you can also do it by integrating the previous question value f of x dx.
Then
If you integrate also, I'm getting the same.
A0.
No, the same whole function f of x.
So, see here. Using this, if I ask you, tell me 1 upon n square, can you find? Can you find? Using this, if I tell you what is summation 1 upon n square, because we read that 1 upon n square is conversion. Now tell me what is the value of 1 upon n square, summation 1 upon n square. Using only this this term. Okay, see, I'll give you a hint. Summation 1 by n square is actually 1 square, 2 square, 3 square, 4 square.
You have all the odd terms. You can write the even terms as 1 by 4 times 3.
Okay. Let me tell. 8 square. Okay. See the magic. 1 by 1 square, 1 by 3 square, 1 by 4 square, 1 by 5 square, 1 by 7 square. These are odd numbers. And summation 1 by 2 square, 1 by 4 square, 1 by 6 square. These are even numbers, right? Now take 1 by 2 square common from this. What we get? We get 1 by 2 square, 1 by 1 square, 1 by 2 square, 1 by 3 square, and so on dot. If I say this is, let's say, alpha, and let's say this is beta, so what we get? We get alpha is equals to beta plus 1 by 2 square into alpha. Very good. Alpha minus 1 by 4 of alpha is equals to beta. So 3 by 4 times of alpha is equals to beta. This implies alpha is equals to 4 by 3 of beta. And what is beta? Very good. Beta is pi square by 8. So this pi square by 6. We did it. We can find, now we find the summation 1 by n square. Until now we only know that 1 by n square is converted. Now we can throw on your mouth that 1 by n square is 1 pi square by 6. Right? Okay. Now tell me one thing. Ready? Okay. We find 1 by n square. Okay. We find 1 by 2n plus whole square, odd number, common. What about even numbers? Can we find?
Alpha by alpha.
Sorry?
Just alpha by.
Okay. Any other answer for this? Okay. We have 1 by n square, we have 2n plus 1 odd numbers, common numbers, and we have to find even numbers. How can we find? Can't find. Sum of odd and even. That's why I just want to listen it. Okay. Someone say sum of odd and even is total. If I say 1 by 2n square is 1 by 4 this square. Is it not correct? This also correct. No need to go there, go here. Or go here. So what you get v pi square by 24. You can get everything about 1 by n square. Until now you know summation of like sum of square of natural number or sum of square of 2n plus 1 whole square or sum of square of even number. But now you get sum of reciprocal of square of natural number, sum of reciprocal of odd number, sum of reciprocal of even number. Interesting. No? No. Okay. So next question. Write it. This is very easy. Very easy. Find again Fourier series of x is equal to x in between minus pi and pi. You have 2 minutes or 3 minutes to find, just find it. Very easy. That's why I am asking. Please find. What is the n? What is the n? 0. What is the n? Anyone other? What is the n? 0. For each n. Actually for each n. A0 is also 0. Like, what is Bn?
2 by n into minus 1 to the power n.
Now,
2 by n times minus 1 to the power n plus 1.
so n is equal to 0 and Bn is equal to 2 by. This is very easy. Using that formula you can find. I'm not going to that. If you have doubt, you can ask me separately. Okay. So x can be written as there is only discontinuity, so that we can write fx x is equal to a0 plus bn sin nx. Sin nx. This is 2 by n from n is equal to 1 to infinity and minus 1 raised to power n plus 1 into sin nx. Right now, pi by 4. Pi by 4. Now the question said you have to prove that summation minus 1 raised to power n upon 2n plus 1. See, this is also again from sequence series. We read minus 1 raised to power n upon n is a convergence series. Is a convergence series. That way we are going to find now what is summation 1 minus 1 raised to power n upon 2n plus 1. So we just put x is equal to pi by 2. by 2 is equals to summation 2 upon n minus 1 raised to power n plus 1 sine n pi by 2. Sine n pi by 2. Now what is sine n pi? What is sine n pi? 0. Sine n pi is 0. So if sine n pi is 0, we can write, see, this is important step is, see very carefully. 2n plus 1, I am going to separate it in odd element. 2n plus 1 minus 1 raised to power 2n plus 1 sine 2n plus 1 pi by 2. And then even numbers. 2 upon 2n minus 1 raised to power 2n plus 1 into sine 2n pi by 2. Is it fine? I first write, instead of n, I write 2n plus 1 and again I write 2n in place of n. Actually this should be k, but I am not using that k because you will deflect from your part. So just write, instead of n, you can write 2n plus 1. In one place 2n plus 1, other place only 2n. So this is going to be n pi. If this is n pi, this is going to be 0. If this is going to be 0, now only have this n. Summation 2 upon 2n plus 1 minus 1 raised to power minus 1 raised to power 2 into this is 1 and sine 2 n pi plus pi by 2 sine n pi plus pi by 2. This is 2n plus 1 and sine n pi plus pi by 2 is minus 1 raised to power n, because sine pi by 2 pi plus pi by 2, then 2 pi plus pi by 2. So this is 2 is coming here, 4 is equal to summation minus 1 raised to power n upon 2n plus 1. Can you find minus 1 raised to power n upon n, as we find here from using this expression minus 1 raised to power n upon 2n plus 1? From there we can get minus 1 raised to power n. Just try. I'm not so sure we'll find or not, but just try for 1 minute. Yeah. For 1 minute just try. Okay, my last question. Just try it and let me know if you find. If you find, you are genius, otherwise you are genius. Question number 7. Question number 7 is very bad. 5 by 6, 1 by 7 is equals to pi by 2. Not so good question. So you have to show that this is going to be pi by 2. Any idea? Hint is you can see like this. This is 1 by 1, 1 by 2, 1 by 3, 2 raised to power 3 common. This is 1 by 2, 1 by 1 by 1, 1 by 2. This is 1 by 1. Ignore this term, ignore this term, and next term ignore this. So this is 1 by 1, 1 by 2, then 1 by 1, 1 by 1, 1 by 2, 1 by 3, something like this. That's why I'm saying this is very not so good question, because this question is not obvious. You have to know something good. So that something good is this. This series expansion. This series expansion is plus mx m minus 1 x square by 2, I think. By 2, yeah. Not 2. Plus m minus 1 m minus 2 1 dot 2 dot 3 into x square, sorry, x cube, and so on dot dot dot. Okay? Yeah. Now, put x is equal to minus t square and m is equal to minus the half. So what we get? We get 1 minus t square raised to power minus half is equal to 1 minus, you see it very carefully, 1 minus t square, and this is going to be minus half minus 3 by 2 upon 1 dot 2 minus t square whole square, something like this. Now this is actually 1 by root of 1 minus t square. We can integrate it and then find the solution. Integrate it, it's going to be sine inverse t. Put t is equals to 1, and we can find from sine inverse t we can find pi by 2, and put t is equals to 1 there, we can find this term. Okay? Got it? After this, integrate it and put t is equals to 1. This is after. This is very easy. After this, very easy. The main concept is this. You can't know. This is very obvious thing, because you have to know the in this form, in this question, this is going to be used. Right? This is not an obvious thing, right? So after this, this is very obvious thing. Like you have to integrate it and put t is equals to 1. If you put t is equals to 1, you can get sine inverse of 1, which is pi by 2, and just integrate it, you can find this one. Okay? Alright. Just write this line after this. Integrate it and put t is equals to 0, we can find it. Okay. Now it's attendance time. You can forget attendance sheet. Not this. And don't move until I finished. You two boys, please don't move. It's very disturbing for me. Okay, I just forget what roll number I am going to ask. Okay, so yeah, please keep 108, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 0, 2, 3, 3, 4, 5, 6, 6, 7, 8, 8, 9, 10, 11, 10, 11, 12, 13, 14, 15, 14, 15, 15, 13, 14, 15, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63.
धन्यवाद आप